All right, section 8.1 is on introduction to conic sections. Garrett, just be nice. All right, conic sections they come from cones. It takes a brilliant person to figure that out, yes. Cones, conic. And so they are different like slices of the cones. Okay, so if I take like a sharp object, think like a guillotine. I take a guillotine and I slice through really fast, I'm going to get different shapes. So if I slice through directly through the center, not through the center, but through the through this way, I get a circle. Okay, if I slice through at an angle, I get what's called an ellipse. Okay, and then I can have a parabola, and I can also have two of them if I do the double cone top to bottom, and that's going to be a hyperbola. It kind of looks like a parabola, but it doesn't have like the same equations. Okay, so it's not a parabola, so it's a hyperbola. Yes. They are opposites, but they're not opposite parabolas. Yes. Yeah. So it's very simple to graph conic sections using an application on your computer called Grapher. So you have something on your computer where you can graph exactly like this is right here with X's and with Y's and so on. Okay. So you have something on your computer that you can do that. But unfortunately, you can't just take your entire laptop into the SAT or the AP Calculus exam or any exam really that you're taking in class, right? You can only use your calculators. So, and your calculators make you solve it for Y. You know how like when you graph things before, it's always Y equals. We're going to try to solve for Y. So we have a little bit of experience for this with this from our last section, section 7.8. Do you guys remember when we like switched our X and Y, solved for the new Y, right? We're going to solve for the Y value in these equations. So you might want to write kind of tiny. I didn't give you a ton of room, and we are going to like do a little rough sketch too. So this first one, it says x minus 1 squared plus y plus 2 squared equals 25. So I'm going to try to get the y by itself. So I'm going to subtract my x minus y, or x minus 1 squared over, struggling. Okay, so I have that. Then I'm going to take the square root of both sides. And when I take a square root, I do a plus or minus. So I'm going to have y plus 2 equals plus or minus the square root of 25 minus parentheses x minus 1 squared. Okay, then I'm going to subtract the 2 over, so I get y equals negative 2 plus or minus the square root of 25 minus x minus 1 quantity squared. Okay, this is not just one function, it's actually two functions. Remember functions past the vertical line test? This is two functions working together. So the first one, I'm going to call it y1, is negative 2 plus the square root part. Okay, and if I was going to put this into my calculator, I'm going to do negative 2 plus the square root of, and the newer calculators will do a parenthesis here. Some of the older calculators don't do that parenthesis. You always need to say square root of what? So parenthesis 25 minus parenthesis x minus 1 raised to the 2, and then the end parenthesis. Okay. And then the y2 we're going to put in as negative 2 plus, or not plus, minus the square root of 25 minus parenthesis x minus 1 parenthesis raised to the 2, end parenthesis. Okay, so go ahead and try that on your calculator. So get your calculators out. Maybe I'll draw a little handy calculator up here for reference. So on your calculator, you have a little button here that says y equals. So you're going to hit the y equals button. And then underneath the y equals, kind of over here, is a button that says x, tau, theta, n. So x, t, theta, n. Do you guys see that? Okay, that's your x button. So you're going to put in negative 2, not minus 2. So this one is a negative sign. These ones are minus signs. So be really careful. Hello. Okay, so you're going to do negative 2 plus the square root of parenthesis 25 minus parenthesis x minus 1 squared parenthesis. Okay. And then the other one, you're going to do negative 2 minus square root of 25 minus parenthesis x minus 1 squared parenthesis. Or raise the 2. Yes?
Can we go back the Second step, after you press y equals, what do you do?
Type all that in, -2 plus, like I'm saying those things. So the negative is where the answer button is. You guys see that down at the bottom next to the enter. And then the minus is just the regular minus subtraction sign.
Is the 20?
You guys have it?
Yes.
Okay. So when you hit graph, it gives you something. Okay. Mine kind of looks, don't draw this, but mine kind of looks like this. And to me, it looks like an ellipse. This is actually a circle. Okay, so your calculator has distorted it a little bit. So maybe some of you guys don't even have the right window. So what you can do is under zoom, so hit zoom. If you hit number 6, it puts the standard -10 to 10 window. Okay, this is the one that, like, when I give you like grids on your homework or whatever, I do a -10 to 10 window. You know what I'm saying? So like it's -10 for the y, 10 for the y, -10 for the x to 10 for the x, like that. Okay, but the problem that's, like, the thing that's wrong with your calculator is it's a rectangular viewing window. Does this make sense? Do you guys understand what I'm saying? If you do the same units, -10 to 10 and then -10 to 10, it's distorted a little bit. Do you guys understand? Like it's not a perfect square in the viewing window. You see what I'm saying? So what we want to do is we want to make each of those little units a perfect square. So what we do is under zoom, do you guys see the one we're going to use? Z square. Do you guys see it? It makes all of our units square. So it's adjusting it a little bit. Now does it kind of look like a circle when you hit Z square?
Oh, yeah.
This is zoom number 5. So if you're deciding if it's an ellipse or a circle, make sure you have like a Z square, right? The zoom square, so you can tell if it is or not. Okay, yes.
Get an error.
If you have an error, you've done one of two things. So look on your, when you hit y equals, do you have plot 1, plot 2, or plot 3? Is that highlighted?
No.
Okay, so that's good. So sometimes when you get an error, one of those things is highlighted and you would just go up and you would deselect. Okay, when you did your negatives and your minuses, that's another thing people will mess up on. So the very first one is -2, but everything else used the subtraction sign. So make sure that you have that as well. Are we good there? You can tell one's little and one's longer.
No, why you look like the little accuracy on the graph?
Uh-huh.
This is like perfect numbers. Why is it like 1.29?
Yeah, they aren't perfect numbers. A lot of them will involve like square roots and things. But it should graph like this. Notice how there's a little space between your two, like the top and the bottom. The top one was the y1, that's this. The bottom one was the y2, that's this one. Okay, it wants to show you that they are two separate functions. So it leaves a little space. There's not actually a space between them. They actually do connect. But your calculator gives a space. I told you what it was. It's a negative sign. -2. Okay. So we have this. What are you talking about? It's a negative sign. -2 plus 2 plus, you know?
No, but it's a negative.
You did the minus sign. You did the long one. You did this. It's this. Okay. All right. Now notice how it says, sketch a rough graph below and identify each conic section, then describe the important points. So first of all, this is a circle, right? The center of the circle is kind of hard to find. You can kind of estimate if you want to. Okay, I'm going to tell you what this one is, and we'll talk about this in the next section. It's going to be 1, -2. It has to do with these numbers here. You see the x minus 1 squared, y plus 2 squared. That's where those numbers are coming from. Okay, I also want to find the x-intercepts and the y-intercepts. So I want to find this point, this point, this point, and this point. Okay, x-intercepts and y-intercepts. Do you guys know how to do an x-intercept by hand? How do I find it by hand? Plug in 0 for the y, right, to find an x-intercept. So here's what I would get if I did it by hand. So just pay attention. Don't write this in your notes. Just kind of pay attention. If I was finding an x-intercept, I plug in 0 for the y. So I would have x minus 1 squared plus 0 plus 2 squared equals 25. So I'd have x minus 1 squared plus 4 equals 25. I'd subtract the 4 over, so I get a 21. So I have x minus 1 squared equals 21. I would take the square root, plus or minus, so I'd have x minus 1 equals plus or minus the square root of 21. And I'd add the 1 over. So I get x equals 1 plus or minus the square root of 21. Those are the x-intercepts. 1 is 1 plus the square root of 21. 1 is 1 minus the square root of 21. If you wanted an exact answer, that's how you would have to do it. But if your calculator, like if someone says just round to the nearest like 3 decimals, then you can use your calculator. You don't have to do all that work. Okay, so let's figure out how to find an x-intercept using the calculator. So what we're going to do, and maybe write yourself some notes. So x-intercept. In order to find it, you're going to do second trace. Do you guys see trace? It's along the top, like right up here. So second trace. And an x-intercept, another word for it is 0, right? So the really old calculators say root. The newer ones say 0. So we're going to do that. So second trace, number 2. Okay, so we're going to select number 2. Okay, and then it says along the bottom, it says left bound question mark. It wants you to get on the left side of what you're trying to find. So this is where our third period was having trouble paying attention. So make sure you're paying attention to this. Okay, if I want to find this x-intercept right here that I'm circling in green, and I want to get on the left side of it along the curve, am I below the point or am I above the point? What's on the left of it along the curve? Do you guys see it's right here? This is the left side of it. So it's a point that's like right there, along the left of it. Okay, we're going to go over. And we're going to get on the left side of it, of the actual x-intercept, and we're going to hit enter. Okay, when you hit enter, what does it say now? Right bound. Where do you think the right bound's going to be?
Right.
It's going to be on the right of it. So you're going to go up. So hit right, like the cursor to the right. Now you're above the x-intercept. Hit enter. Livy, you want to be looking at someone's calculator. So get to a place where you can see someone. Maybe come over here with Kelsey. Hit enter. Now what does it say?
Yes.
Guess. Guess means get exactly where you think it is. So guess is going to be right in between. It's going to be right where you think that x-intercept is. Hit enter. Do you guys see what it says?
No sign change.
That means that you weren't below and you weren't above the axis. So try it again. You should get negative 3.583. Did you guys get that? Okay, so we'll do the same thing over here. So same instructions. Yes.
I think there's something wrong with my calculator. Because when I go to 0 and hit enter, it just goes to.
They should go to the graph. Okay. Bring it over here. All right, same thing. Yes.
When you say the left bound question mark, when do you enter?
You want to get on the left of what you're trying to find. So if you have some kind of curve that looks like this, guys, and I want this x-intercept, the left of it is down here. That is on the left side of the curve because the curve is increasing, it's going up. You can see so the left side would be here, the right side would be up here if my x-intercept's here. Do you guys understand what I'm saying? So left is going to be there, right will end up being here. Okay, but if something's decreasing, when you talk about the left bound, it's here, and when you talk about the right bound, it's down here. Okay, you're getting on both sides of that curve, left side and right side. You're sandwiching the x-intercept between them.
I think I know what's wrong. Because when I did the y equals, I had the things, and then when I clicked go around, it just did one of the things. And so I think I just have to change.
Yeah, you basically just have to. Like the other both highlighted. Hit enter. It's on the
Well, at least you have two circles.
so make sure both of them are highlighted.
I just have one. No,
All right, guys, same idea. Can we do this? Left bound, right bound. So the left side is going to be above on the right side, like on this other x-intercept. We're above, right? Left side's above. And then the right side is below. Do you guys see? Because the curve is kind of going like this. If I'm finding my x-intercept, left is above, right is below. And then what I want is going to be, we'll go guess exactly where we think it is. Okay, so I'm doing second trace. I'm finding the 0. I'm taking my cursor over. I'm going to get really close to the x-axis, but I'm going to be a little bit off of it on the left. And then I go to the right, and then it says guess. What do you guys get? .583, 0. Did you guys get that? No. Where did I lose you? Yeah, Chloe.
I used to get it. Yeah, I got a 0. 6.5. 5, 7, 5. I got a number. I'm just trying to back.
I didn't get an error.
My y is 0. It's supposed to be 0. We got 5. Just not the point.
That's great. Wait, like 5.8.
It should be 5.583. Guys. Okay, what you guys, when you're just telling me these numbers like, I got 6.5, that means that all you're doing is you're tracing along the curve. Like, that's not giving you anything. If you just hit the trace button and you're tracing along the curve, that's like very imprecise. Those are not really precise things. You can't exactly get y equals 0. Do you understand what I'm saying? So you need to do second trace. You need to go to 0. You need to get on the left side, hit enter. Get on the right side, hit enter. Go to where you think it is, hit enter. You should have 5.583. Okay, then you have something, like if you're doing your second trace, and as you're finding your 0, if you are not above the axis and below the axis, it's not going to give you the 0. You have to sandwich that x-intercept between two values. Okay?
So how do you guess?
Guess is just where you think it is. Go to where you think it is, hit enter. All right, second one, part B. So part B, we're going to solve for y. This one's an easy one. This should be, sorry, there's no y there, is there? It should be 9y squared. I made a typo. Do you hear me? I made a typo. 4x squared plus 9y squared equals 36. Yes.
So when I push S, it keeps it on the circle. It won't let me leave the circle.
Hit enter.
I didn't push it.
Then what did you get?
I keep on getting bound there.
You need to be on the above and below.
Yeah, no, I did.
Bring it to me. All right. Solve for y. So I've made a typo, put the y in. Subtract, guys, this is not that hard. You're making this very, very hard. Listen to what I'm saying. It will be fine. Subtract the 4x squared over. So you get 9y squared equals 36 minus 4x squared. This is the point of the lecture where someone always says, where did you get 9y squared? And I tell you, I just told you you had a typo 3 times.
So you push enter. Top.
Divide by 9.
So after enter top, no, right down you go down.
You're not going down.
Oh, okay, down. Now.
Arrow, arrow,
Push
enter. Guess, guess where you think it is, hit enter. That's your 0.
Oh,
It's not a piece of junk. It's a user error.
That's not happening.
Divide by 9, divide by 9. So you have y squared equals 36 minus 4x squared over 9. Take the square root of both sides. Right, plus or minus. Yeah, how about you pay attention to this one? So I get y equals plus or minus the square root of 36 minus 4x squared over 9. Now, it's kind of hard to put this in when you have like a quotient under your square root. So if possible, if you can take the square root of the numerator and the denominator, it will make your life a lot easier. So what we're going to do is I'm going to do the square root of both the top and the bottom. The square root of the top just stays the square root of 36 minus 4x squared. The square root of the bottom, square root of 9, is just 3. Okay, why can I not take the square root of 36 minus 4x squared and say that it is 6 minus 2x? Is that true? Math. Math gets in the way. You cannot say that. You can't just take the square root of each individual piece, because think about, remember my freshman dream that I told you about? If you have 6 minus 2x and you square it, like going the other way, it is not 36 minus 4x squared. You're just doing the freshman dream backwards when you do that. Like you would have to FOIL that out. You'd have to do 6 minus 2x times 6 minus 2x. Yes. No. That's always been the freshman dream. Okay, and then the next one. The next thing I was going to mention is if you have the square root of 9 plus 4, think about that. Is that 3 plus 2? No, because it's the square root of 13. Is the square root of 13 equal to 3 plus 2? No, 5 is not equal to the square root of 13. That's not how math works, as Kyle said. It's not math. Yes?
Is math ever the simplest?
Yes. All right, so we're going to have two functions that we're putting in because we have that plus or minus, okay? So I'm going to put in y1 equals, I'm going to do square root of parentheses 36 minus 4x squared. And then I end my parentheses over 3. Okay? And then do the second one. So for y2, I have negative square root of 36 minus 4x raised to the 2 divided by 3.
How much? I don't got one line.
Do you have to go down and then you go over in a second?
It doesn't work though. It's not gonna, it's just the exact same thing.
So square to the top takes the square to
No
the
matter
bottom.
what. I'm only getting one line every time.
If you're only getting, this is why you should be telling me that you're getting these things, guys. Don't just continue to do it the wrong way every single time and just be like, oh, something wrong with the calculator. There's not something wrong with the calculator, doing it wrong. If you're only getting one of the pieces, it's because under your y1 and your y2, when you have your equal sign, one of them is highlighted, one of them is dark, one of them is not highlighted. So go on top of the equal sign, hit enter, and it will highlight it.
It's still stupid.
Okay, then when you hit graph, it will give you both.
So for the y2, is it the negative symbol or the?
It's the negative.
It's
Negative
just
square root.
unhighlighted.
Because you're not subtracting it from anything, right? There's nothing in front of it.
It's somehow unhighlighting itself. And I hit graph.
The graph start making the object, it will just stop and then just go through there.
Okay, that means you have something wrong in the second. So Yaya said when he's graphing his, it graphs the first one, and then it starts to graph the second, and then it says error. If it's saying error, that means there's something wrong with your notation in the second one. So maybe you had a minus sign instead of a negative, right? You have to have a negative right here. Whoops, I deleted it. You have to have a negative right here because there's nothing in front of it to be subtracting from. Like you can't have a minus because it's not like 2 minus that. There's nothing there. So it's subtracting from nothing. Yes?
I highlighted both equal signs and then pressed graph, and it's just unhighlighting.
I don't know.
So between 36 and 4, that's supposed to be a negative sign?
No, between 36 and 4 is a minus sign. In front of everything is a negative.
Yes.
Oh, you know, the Google glasses and stuff. Oh, I did it again.
Yeah.
I feel like rocket science is actually easier without a graph.
All right. Okay, when you graph it, what do you get? Is it a circle or is it an ellipse? It's more like an oval? Okay, so you want to see if it's an oval by doing that zoom square. Did you guys do that? It's definitely an oval, right? It's an ellipse, as we call it. Okay, so you're going to have, it's kind of longer along the x-axis than it is along the y-axis, so we call it a horizontal ellipse. It's an ellipse. All right, now this one, you can do the x-intercepts and y-intercept things. Oh, I didn't even do the y-intercept on the last one. You guys took so long in the x-intercept, I forgot the y-intercept.
What if you 0, 0?
Of course, you've deleted it out now, haven't you? All right, in order to find the y-intercept, we'll do it on this one. In order to find a y-intercept, it's much easier. A y-intercept, you just do second trace, but you don't do that number 2 anymore. You don't find the 0. That's not a 0. You want to find the y-intercept. There's no choice that says y-intercept, right? So what we do is we do value, which is number 1. And then when you hit that on your calculator, it says x equals. You want to put in 0, because you want it for the x value of 0, right? So when you hit x equals 0, what does it give you for this ellipse?
2.
It gives you 2. So you have 0, 2. And then what about down here? Yeah, how do I get that to show up?
You put negatives.
No, you just arrow down. If you arrow down, it will give you the other x value. Does that make sense? It takes you to the other curve. So you have 0, -2. All right, now the sad thing is you can't do the left bound, right bound thing on this one. Okay, you would have to actually, guys, you would have to actually plug in y equals 0 to find the x-intercepts. Okay, but it's not super hard. Like, you know how to do that in this equation, in the original. If you plug in y equals 0, you can pretty quickly see that x is going to be 3. But the nice thing is you can also see it on your graph, right? Like, if you look at your graph, can you see it's 3, 0, and negative 3, 0? Those ones aren't hard to see. It was centered at 0, 0, so it's pretty easy. Okay, so I'm gonna call these certain names. So on the circle, all you have is a center, and you have the length, which is the radius. We'll be talking about that in the second section. For these, we have what we call a vertex. Both of these are vertices. So 3, 0 and negative 3, 0 are vertices. The co-vertices, so co-vertex and co-vertex, are the other ones. So the shorter sides have the co-vertex, the longer sides have the vertex. Okay? Vertices, co-vertices. All right, that's all the important points. The center is the 0, 0 in this case. Okay, so what about part D? Can you tell what shape that's going to be without even graphing it?
What did that just do, like a slope kind of thing?
No. It's a parabola, not a line, it's a parabola.
Sounds right.
All right, so this is going to be a parabola. You know from your transformations that it's a downwards parabola. Right? You can put this in for y1 if you do negative, parentheses, 1 divided by 2, x raised to the 2. So put it in like that. So negative 1/2, x raised to 2. Yeah?
Why isn't it minus parentheses negative 1?
You could do the minus inside the parentheses, doesn't matter. Okay, and we get that curve. So you can pretty easily see it goes through 0, 0. So that's your vertex. Oops, vertex. Now, whenever we've done t-tables in class, I have very quickly given you values on t-tables. Have you guys ever noticed that? Have you just been like, wow, Mrs. Cox is really good. She can do a lot of this in her head. Okay, if I have a really complicated polynomial and I ask you for a t-table, the easiest thing to do is to use your calculator's table. Do you guys see how you have a little thing that says table on your calculator? So the button is like right here, but you have to do second in order to get to it. Do you see how it says table above? Yeah, so if I wanted to get a t-table, you guys already have a set list of numbers that you can do. Like you can scroll up, you can scroll down. Do you guys see that? You can find all these different values. But what if I asked you like 0.5? Okay, some of you guys have tables that will not let you change that. Okay, so pay attention. I'm going to tell you how to change this. Kyle. So if you want to change your table so you can put whatever values you want to put in, what we do is we do second table set. Table set is along the top of, what is it, like a window?
Yeah, it's the second one.
It's a second window. And you have lots of different options. So the first thing it says is independent, and then it has auto, and it has ask. I want you to highlight ask and hit enter. And then for your dependent, I want you to keep that as auto. Okay, so you have those two things highlighted. Do you guys have that? And then do second quit, so get out of there. Second quit. You'll do second quit a lot when you're trying to get out of it. So now when you hit table, you'll have a blank table, which at first you kind of panic. You're like, where did all my points go? Oh my gosh. But it's really not that bad because now you can put whatever points you want. So if I want to put in 1, 2, -1, -1.5, I can do that. I can put in whatever values I want, and it gives me the table. Yes? It didn't go blank. There's still things there. Did you highlight the ask? Okay, can you put in new numbers? All right, so let's say I wanted to know where 1 was. If I plug in 1, I get -0.5, right? If I plug in -1, I get -0.5. These aren't special points in the parabola, but it would help if you're graphing the parabola to know how fat it is, right? How much it's opening. or how quickly it's opening. So if you plug in 2, you can get a certain number. So it helps you graph the parabola. Okay, and this last one. So I'm going to solve for y, so I'm going to add the 4x squared over. So I get y squared equals 4x squared plus 16. I take the square root, and I write plus or minus. So I get y equals plus or minus the square root of 4x squared plus 16. So that's going to be y1, and then y2 will be the negative one, right? Yes? Yeah, I put it in 2 separate. I put y1 was plus and y2 is minus. Okay, so go ahead and graph this one. Again, you can't just take the square root of each individual piece and say it's 2x plus 4. That would be a line. It's not going to be a line. What shape do you get now? You should get a hyperbola. So you guys get a hyperbola? So you graph the top, and then I graph the bottom? Yep, good. All right, now the important points on a hyperbola right now is just going to be these 2 points right here. Those are called the vertices, vertex. Can you tell what it is? Uh-huh, 0, 4, and 0, negative 4, right? And you could get that by value, or you could go to your table, whatever you want to do. Okay? So there's lots of different things your calculator can do. Your calculator can also find maximums and minimums, which we'll talk about eventually. Right? It can do a lot of things for you. The bad thing about the calculator, though, is it doesn't give you exact values. Remember that one where we had like 1 plus the square root of 21? It's not going to give you that. It's going to give you a decimal approximation. Okay, so that's kind of the downfall of using the calculator. You don't get those nice exact answers. And you don't always get to use your calculator, right? Sometimes you have a calculator portion and a non-calculator portion. All right, so at the bottom it says a parabola is a single curve, while a hyperbola consists of 2 curves. They're not perfect, like they're not parabolas. Don't think they're exactly the same shape as a parabola. So in the equation for a parabola, it will have an x squared or a y squared, but it's not going to have both. It's not going to have x squared and y squared. So for instance, on C, I have y equals negative 1/2 x squared. What do you think it would look like if I had x equals, I don't know, like 4 y squared? What's that then? Yeah, so you would do like divide by 4, and then you would take the square root, and you do plus or minus. So it is going to look like a square root of x function, but it's also going to look like the negative square root of x function. Do you guys see it? It's a parabola that would be on its side. 2 functions put together to make a parabola on its side. Okay, so you could have parabolas like that. So in this section, we're not only going to, or in this chapter, we're not only going to do parabolas go up and down, we're going to have parabolas that are on their side, going to the right or to the left as well. So we're going to do lots of different things. Okay, every other conic section will have both x squared and y squared terms, except for parabolas. So that's kind of a red flag whenever you see only an x squared or only a y squared, that's when you know it's a parabola. Conic sections are all defined by distances, and for this entire chapter, we're going to be using the midpoint and distance formulas. So let's talk about a circle. So the distance formula. Anybody remember the distance formula? Nope, not that distance formula. I heard rate times time, not that one.
Square root of x2 minus x1.
Yep, square root of x2 minus x1 squared plus y2 minus y1 squared. And a lot of people freak out when they see this formula. You don't have to freak out. It is only a glorified Pythagorean theorem. That's all it is. So let me sketch out what I'm talking about. So let's say I have a point, it's at, I don't know, 1, 2. And then I have another point way up here, let's say it's at 8, 10. If I want to find the distance between those 2 points, what I do is I draw in a right triangle. I go straight over and straight up, and I create a right triangle. I could have also gone over the other way. I could have gone like here too. Doesn't matter. Oops, lost it. Okay, so let's think along the x-axis. If I'm starting at 1 and I'm going over to 8, how many units separate those two? 7. So that means that this distance along the leg of my right triangle is 7. Do you notice how it was just x2 minus x1? 8 minus 1 gives you 7. Okay, what about the 10? So I have a height of 10, and I have a height of 2. What's the distance there? 8. So in order to find d, which is the distance separating those 2 points, I would do 7 squared plus 8 squared equals d squared. In other words, d is equal to the square root of 7 squared plus 8 squared. Do you guys see where it's coming from? So the 7 was just the x2 minus x1. The 8 was the y2 minus y1. That's where it comes from. And it even works when you have negatives. Like if it had been way over here at -6, well, the distance here is 14. It's 8 minus a -6. It still works even if it's in the negatives. Okay? So if you want to memorize the distance formula, all you need to do is memorize the Pythagorean theorem. That's what it is. You can always draw it a little right triangle if you need to. Okay, the midpoint formula. Anybody know that one? It's only been a year since you've been in geometry. Yeah? Emily? X1 plus x2 over 2. Is that what you said over there? And then it's y1 plus y2 divided by 2. Notice how I'm writing it as a point. It's called the midpoint. So I write it as a point. Parentheses and a comma. Okay, so number 1 says find the midpoint of the line segment with these endpoints. So I can label x1, y1 if you need to, x2, y2. What I'm doing is I'm averaging my x's. So this is the average of the x's and the average of the y's. That's all I'm doing. I'm saying, like in my picture, if I'm between 1 and 8, I want to find the thing that's directly between 1 and 8. So I want to go over to half of them, which would be 1 plus 8 is 9, divided by 2 is 4.5. I want to go over to 4.5. And then if I'm separating 10 and 2, 10 plus 2 is 12, divided by 2 is 6. That gives me the midpoint. It's halfway for both of them. It's like I go over half, up half to get to that point. Do you guys see what I'm saying? You understand? Okay, so I'm doing the average of the x's and average of the y's. So my midpoint for number 1 is going to be 5 plus 3 divided by 2, comma, -2 plus 7 divided by 2. So I get 8 over 2, which is 4. And I get 5 over 2, which I can leave as 5 over 2. Or I can write 2.5. So either way. Okay, so that's the midpoint. Okay, I think it's break time. All right, go on a quick break. So the midpoint formula is pretty straightforward when you're just asked to find the midpoint between 2 points. But there are other types. So sometimes, guys, sometimes it says you have one of the endpoints and then you need to find a midpoint. Okay, so there's a really easy way to do this. And then there's a more complicated way. I'm going to show you the shortcut. Since you guys are all returned to class on time and everything, you get to get a shortcut. So what you're going to do is you're going to line them up. So you're going to say one of the endpoints is at 4, 7. And then the midpoint is at 2, 9. Okay, the other point, we don't know what it is. Okay, we need to think about how I transition from one x value to the next value, x value. So if I go from -4 to 2, what have I added? 6. Okay, so then when I add 6 again, that puts me on the other end, right? So what am I at? 8. What about this one? If I start at 7, I add, yep, and when I add 2 again, 11. Now, unfortunately, they're not always this easy. Sometimes, like on the SAT, they'll give you things where it's like, you have the point R, S, and you're going to the point P, Q. Like, they're really weird. They'll just put in a whole bunch of variables. Okay, so you really need to know the other way of doing this as well. Okay, so here's the long way. So basically, you take your endpoint, and you want to pair it with another endpoint. So let's say my endpoints are -4, 7, and some other endpoint, x, y. If I'm finding the midpoint between these two, what I'm doing is I'm adding the x values together and dividing by 2, comma, adding the y values together and dividing by 2, and writing it as a point. That has to equal the midpoint, 2, 9. So when I set this up, I say -4 plus x over 2 equals 2. And I say 7 plus y over 2 equals 9. And I solve both of these equations. So I multiply the 2 over, so I get -4 plus x equals 4. and I add the 4 and I get 8. I multiply the 2 over, I get 18. I subtract the 7, so I get 11. Do you guys see how you end up getting exactly the same thing? 8, 11. Okay, but it's a little bit harder. Okay, so number 3, it says find the other endpoint if one of the endpoints is 3, negative 9, and the midpoint is at 10, negative 19. So let's set it up with the shortcut. So I have 3, negative 9. The midpoint is going to be between it. It's going to be 10, negative 19. So I want to think about how I transition from the x values and then to the y values. So my x, I add 7, so I get 17. And the y's, I subtract 10, so I get negative 29. That is your endpoint. Make sense? Okay. So then we have the distance formula. So it says find the distance between each pair of points, leave as a simplified square root if necessary. So I will usually never want the decimal answer. I'll usually want it to be written as like 3 root 5 or something. Okay. So the first one, if I find my distance formula, remember it's x2 minus x1 squared plus y2 minus y1 squared. Okay, so my distance is going to be 12 minus a negative 3 squared plus negative 3 minus a 5 squared. So I get 15 squared plus negative 8 is squared. Make sure you're really careful if you're putting this in your calculator, because a lot of people will not put negative 8 in parentheses, and then they'll get negative 64. So you get positive 64 plus 225. So we get the square root of 289. Anybody know what that is? Good. Yep, 17. So that one came out nice. Okay, the next one. So if I have my distance formula, I'm going to have 1.5 minus a negative 0.5 squared plus 0 minus a negative 6 squared. So I get 2 squared plus 6 squared. So I get 4 plus 36. So I have the square root of 40. And then don't give me the decimal answer, give me the simplified answer. Do you guys remember simplifying square roots? Yep, 2 square root of 10. So it's square root of 4 times square root of 10, which is 2 root 10. Okay, pretty easy. Distance formula isn't bad. C you can do if you want. I think it's 4 root 2. I think it ends up being like the square root of 32 maybe. I don't know. I don't remember. All right, number 5. So find the center and radius of a circle that has diameter with endpoints 5, 4, and 0, negative 8. So some of you are very visual. If you need to see a picture, that's fine. But here's what's happening. So you have 5, 4. And then you have 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that's the diameter of the circle. Okay, so we have some kind of circle. That's terrible. It's like a terrible circle. All right. So some kind of circle connecting here. Not much better. All right, and it asks for the center and the radius of the circle. So how do I find the center? I find the midpoint, right? So my center is going to be m for midpoint. 5 plus 0 divided by 2. 4 plus a negative 8 divided by 2. Always adding, don't subtract, like slope. So I get 5 over 2, which I'll write as 2.5, and then I get negative 4 over 2, which is negative 2. And it should always kind of look like where it's located. If I go over to 2.5 and down 2, do you guys see how that looks like the center? If you're getting 2.5 positive 2, that's clearly not right. So it is kind of nice when you draw it out, right? Okay, now how about the diameter? Or how about the radius? What do I need to do? You can do a couple different things. Doesn't matter. Huh? How do I find the radius? Half the distance for the diameter. So let's find d for diameter, or distance. And we'll use the distance formula. So I'm going to have 0 minus 5 squared plus negative 8 minus 4 squared. So I get 25 plus negative 12 squared is 144. So I get the square root of 169. Did anybody know that one? Yep, good. You guys are good at your squares. We get 13. That's the distance from one endpoint of the diameter across the other endpoint, the whole diameter. So if I want the radius, it's just your diameter divided by 2. So 13 over 2 is 6.5. So you could have done this a couple different ways. Some people are like, oh, I want to take the center and go to the one of the endpoints and use the distance formula. And then you just have the radius right away. You could do that. But I usually go from the 2 endpoints that I was given just because, like, what if you make a mistake on the center? And then you've missed this as well, you know? So if you make a mistake, at least you're getting the point for the radius. Okay. So that's going to be 8.1. So let me pass out your homework really quick. And then we'll start 8.2 in a little bit.